Global ISO certification, inspection, testing, and technical training for railway assembly and manufacturing companies worldwide. Hello everyone and welcome to our channel. Today we are going to explore one of the world's most important and rapidly growing industries, the railway assembly and manufacturing industry. Railways are the backbone of economic development. Every day, millions of passengers and millions of tons of freight travel safely across thousands of kilometers of railway networks worldwide. Behind every reliable train, every metro coach, every freight wagon, and every locomotive is a vast manufacturing manufacturing ecosystem that depends on engineering excellence, precision quality assurance, and international compliance. As railway infrastructure continues to expand across Asia, Europe, the Middle East, Africa, Australia, and the Americas, manufacturers are expected to produce products that are safer, stronger, more reliable, and fully compliant with international standards. This is where quality management, inspection, testing, auditing, and technical training become essential. In this video, we will discuss the railway manufacturing industry, the importance of international quality standards, inspection and testing requirements, supply chain quality management, and how URGS International Certification and Inspection Private Limited helps railway manufacturers and suppliers achieve global excellence. Let us begin. Understanding the railway manufacturing industry. The railway manufacturing industry is much larger than simply building trains. It includes thousands of companies that design, manufacture, inspect, assemble, test, and maintain railway products. These companies produce passenger coaches, freight wagons, electric locomotives, diesel locomotives, metro rail coaches, high-speed trains, bogies, wheel sets, axles, couplers, braking systems, suspension systems, railway doors, HVAC systems, electrical panels, traction motors, power converters, pantographs, signaling equipment, communication systems, railway electronics, track components, sleepers, fasteners, steel structures, bridges, fabricated assemblies. Every one of these products must function perfectly under demanding operating conditions. A single component failure can lead to service disruption, increased maintenance costs, or serious safety risks. Therefore, manufacturers must ensure that every component is designed, manufactured, inspected, and tested according to strict quality standards. Global growth of the railway industry. The railway industry is experiencing remarkable growth across the world. Governments are investing heavily in high-speed rail corridors, metro rail systems, urban transportation, freight corridors, dedicated freight rail networks, railway electrification, smart signaling systems, sustainable transportation, green mobility projects. Countries such as India, China, Japan, Germany, France, the United Kingdom, US, Australia, Saudi Arabia, UAE, Qatar, and many African nations are making substantial investments in railway infrastructure. As a result, railway manufacturers are expanding production capacity and strengthening their global supply chains. This growth creates tremendous opportunities for OEM manufacturers, fabrication companies, heavy engineering companies, steel manufacturers, electrical equipment suppliers, automation companies, inspection agencies, testing laboratories, certification bodies, technical training providers. However, with greater opportunities come greater responsibilities, as we know this. Customers now expect products that meet international standards for quality, safety, reliability, environmental performance, and occupational health and safety. Challenges faced by railway manufacturers. Although the industry is growing rapidly, railway manufacturers face several significant challenges. One of the biggest challenges is maintaining consistent product quality across large-scale production. A railway coach contains thousands of individual parts supplied by hundreds of different vendors. If even one supplier delivers substandard materials, it can affect the performance of the final product. Another Another challenge is compliance with international customer specifications. Global railway projects often require compliance with multiple standards, customer requirements, and technical specifications. Manufacturers must also manage material traceability, welding quality, dimensional accuracy, corrosion protection, surface finishing, mechanical strength, fatigue resistance, documentation control, inspection records, testing reports. Supply chain management is equally important. Many railway manufacturers depend on Tier 1, Tier 2, and Tier 3 suppliers located in different countries. Ensuring consistent supplier quality requires regular audits, inspections, and performance monitoring. Production delays, material shortages, welding defects, dimensional deviations, coating failures, and documentation errors can all impact project schedules and customer satisfaction. To overcome these challenges, manufacturers require strong quality management systems supported by experienced inspection and certification partners. Why quality is critical in railway manufacturing? Quality is not simply about meeting specifications. Quality is about ensuring passenger safety, operational reliability, long service life, and customer confidence. Every railway product operates under demanding conditions, including heavy loads, continuous vibration, high operating speeds, extreme temperatures, moisture, dust, corrosive environments, long operating hours. Poor quality can lead to equipment failures, costly repairs, operational downtime, warranty claims, and safety incidents. That is why leading railway manufacturers invest heavily in quality assurance, process control, inspection, testing, employee competency, and continuous improvement. International customers also evaluate manufacturers based on their quality systems, technical capabilities, superior performance, and compliance with global standards. This makes certification, inspection, and technical competence essential for long-term success. Now transition to the next section. Now that we understand the global railway manufacturing industry, its growth, and importance of quality, the next part of this video will focus on the complete railway manufacturing process, international quality standards, ISO certifications, supplier quality management, and the critical role of inspection and testing in delivering safe, reliable, world-class railway products. Stay with us as we continue exploring how manufacturers can build stronger businesses through quality, compliance, and operational excellence. Railway manufacturing process, ISO standards, inspection and quality assurance. Introduction to part 2. Welcome back. In the first part of this video, we explored the global railway manufacturing industry, its rapid growth, and why quality, safety, and compliance are critical for every railway project. Now let us take a closer look at how railway products are manufactured and how international quality standards help manufacturers deliver reliable and safe products to customers around the world. The railway manufacturing process. The manufacturing of railway products is a highly controlled and systematic process. Whether it is a passenger coach, freight wagon, metro coach, locomotive, bogie, or railway component, every product passes through several stages before it is delivered to the customer. The process begins with engineering design. Experienced design engineers prepare detailed drawings, 3D models, technical specifications, and manufacturing plans based on customer requirements and applicable railway standards. Once the design is approved, procurement of raw material begins. Manufacturers source steel plates, stainless steel, aluminum, forgings, castings, pipes, structural sections, electrical components, braking systems, bearings, wheels, axles, cables, fasteners, and numerous other materials from approved suppliers. Supplier qualification is an essential step because the quality of the final product depends heavily on the quality of incoming materials. Every material received at the factory undergoes incoming inspection. Quality engineers verify material test certificates, chemical composition, mechanical properties, dimensions, surface condition, heat numbers, traceability markings. Only materials that meet specifications are released for production. Fabrication and assembly. After inspection, fabrication begins. This stage includes cutting, bending, rolling, machining, drilling, grinding, forming, welding, assembly. Large railway structures such as coach bodies, wagon frames, locomotive chassis, and bogies require precise fabrication. Modern manufacturers use CNC machines, robotic welding systems, laser cutting machines, automated bending equipment, and advanced measuring instruments to achieve high accuracy. Welding is one of the most important operations in railway manufacturing. A poor weld can reduce structural strength and affect the safety of the entire railway vehicle. Therefore, manufacturers develop qualified welding procedure specifications, commonly known as WPS, supported by procedure qualification records and qualified welders. Throughout fabrication, inspectors continuously monitor welding quality, dimensions, alignment, fit-up, and workmanship. Surface preparation and painting. Once fabrication is completed, products undergo surface preparation. This includes salt blasting, sand blasting, cleaning, degreasing, surface profile measurement. Proper surface preparation ensures excellent addition of protective coatings. Painting systems are then applied according to customer specifications. Customers provide specifications. Based on that, painting systems are then applied. Depending on the application, coatings may include zinc-rich primers, epoxy coatings, polyurethane finishes, fire resistance coatings, anti-corrosion systems. Inspectors verify coating thickness, adhesion, curing, and visual appearance before the product moves to the next stage. Final assembly and functional testing. The fabricated structure is then assembled with various mechanical and electrical systems. This may include doors, windows, seats, air conditioning systems, brake systems, electrical wiring, lighting, communication equipment, driver controls, traction equipment, safety devices. Each system is tested individually before complete functional testing is performed. Only after successful testing does the product proceed for final inspection. Then next is importance of ISO management systems. Quality cannot be achieved through inspection alone. Please keep this in mind. It begins with a well-designed management system. This is why internationally organized ISO standards play a much important role in railway manufacturing. One of the most widely implemented standards is ISO 9001, which helps organizations establish an effective quality management system. ISO 9001 focuses on customer satisfaction, process control, risk-based thinking, continuous improvement, documented information, corrective actions, performance monitoring. Manufacturers certified to ISO 9001 demonstrate their commitment to delivering consistent quality and meeting customer expectations. Environmental responsibility is equally important. ISO 14001 provides a framework for environmental management systems. It helps organizations reduce environmental impacts, improve resource efficiency, manage waste responsibly, and comply with environmental regulations. Employee safety is another key priority. ISO 45001 enables organizations to identify workplace hazards, reduce occupational risks, improve employee well-being, and build a strong safety culture. For railway manufacturers, these standards work together to strengthen operational performance and improve customer confidence. ISO/TS 22163 IRIS standard. In addition to general ISO standards, the railway industry has its own specialized quality management standard. ISO/TS 22163 22163, or formerly known as the International Railway Industry Standard IRIS. This standard is specifically designed for organizations involved in railway manufacturing and supply chains. ISO/TS 22163 focuses on railway specific process management, project management, configuration management, product safety, reliability, RAMS considerations, supplier performance, risk management, product life cycle management, performance evaluation, continuous improvement. Implementing ISO/TS 22163 helps manufacturers enhance operational efficiency, strengthen customer confidence, and compete successfully in international railway projects. Now next is third-party inspection. Independent inspection is one of the most effective methods for ensuring product quality. Third-party inspection, commonly known as TPI, provides objective verification that products comply with customer specifications, applicable standards, and contractual requirements. Inspectors monitor production in different stages, including raw material verification, in-process inspection, welding inspection, dimensional inspection, assembly inspection, painting inspection, final inspection, packing and dispatch verification. Independent inspection provides confidence to both manufacturers and customers while reducing the risk of costly quality issues. Factory acceptance test (FAT) and site acceptance test (SAT). Before equipment leaves the factory, manufacturers conduct a factory acceptance test or FAT. During FAT, customers and inspectors verify that equipment performs according to approved specifications under controlled factory conditions. Once equipment reaches the installation site, a site acceptance test or SAT confirms that the system operates correctly in its actual working environment. Successful FAT and SAT reduce commissioning problems and help ensure reliable long-term operation. Material testing and non-destructive testing. Material testing verifies that raw materials and finished products meet specified mechanical and metallurgical requirements. Common tests include tensile testing, impact testing, hardness testing, chemical analysis, bend testing, metallographic examination. Equally important is NDT, which detects defects without damaging the product. Common NDT methods include visual testing, ultrasonic testing, magnetic particle testing, dye penetrant testing, radiographic testing, phased array ultrasonic testing, time of flight diffraction. These techniques help identify cracks, porosity, lack of fusion, inclusions, laminations, and other discontinuities before products are delivered to customers. Now, quality assurance and documentation. Inspection and testing alone are not enough. Every activity must be properly documented. Typical quality documents include inspection testing plans, ITPs, material test certificates, welding records, NDT reports, dimensional inspection reports, calibration certificates, paint inspection reports, FAT reports, SAT reports, final inspection reports, manufacturing record books. Accurate documentation ensures complete traceability and demonstrates compliance with customer and regulatory requirements. Transition to part 3. Now that we have explored the complete manufacturing process, international management systems, inspection methods, and testing requirements, the next part of this series will focus on supplier quality management, vendor qualification, factory audits, global supply chain excellence, technical training, and how URGS International Certification and Inspection Private Limited supports railway manufacturers worldwide in achieving operational excellence and global competitiveness. Please like and subscribe our channel for further videos. Thank you.